Good morning, students. I hope you all are well and doing mathematics comfortably. These days, we people are doing a very important concept of abstract algebra, that is group, that is samoon. We have already defined the word group. Let us revise this one and we will develop some problems on this, how to prove the given algebraic structure as a group. So let us continue. Group means the pair. पेयर मीन्स युग्म, जिसको जोड़ा भी कहते हैं. टू आइटम्स एट ए टाइम. जी जो है दैट इज नॉन एम्प्टी सेट. स्टार दैट इज बाइनरी ऑपरेशन. This pair is called a group if J is closed under this. Generally, we do not use this one because it is already mentioned that Z is a non-empty set विथ बाइनरी ऑपरेशन. इसका मतलब ही ये है कि जी जो है वो क्लोज्ड है, लेकिन फिर भी हम इसे प्रूव करते हैं, हम इसे लिखते हैं हम अपनी सुविधा के लिए. सो जी इज क्लोज्ड अंडर दिस, दैट मीन्स फॉर ऑल ए कॉमा बी बिलोंग्स टू सी implies belongs to C. J के सारे अवयवों के लिए कंपोज्ड पार्ट भी उस J का मेंबर होना चाहिए. I repeat again with the popular example. In one pocket you have set of natural numbers, in other pocket you have set of natural numbers. Pick up any two natural numbers, add them. If the answer is again a natural number, then the addition is a binary composition. This is the fundamental thing. So here it is. Consider any two members of Z, compose under the given composition, under the given operation. The answer must be in Z. Then we say star or the operation is binary composition, or in other words we say J is closed under this particular operation. Second is associated. This is associated. Third, G contains identity element of this. And fourth, every element of Z has its inverse in Z. Every element of Z has its inverse in Z with respect to the binary operation. These four things we must remember. आपको ये याद करना है, आपको ये ध्यान में रखना है. दिस इज एल्जेब्रिक स्ट्रक्चर, बीजीय निकाय है ये एल्जेब्रिक स्ट्रक्चर जिसमें केवल एक बाइनरी ऑपरेशन है. एल्जेब्रिक स्ट्रक्चर इज दैट which contains a non-empty set and one and more binary compositions satisfying some properties. So here this is the simplest one. Group is an algebraic structure. यदि ये algebraic structure है, ये बीजीय निकाय है, तो तीन बातें हैं. नॉन एम्प्टी सेट होना चाहिए जो कि यहाँ पर जी है. बाइनरी कंपोजिशन होना चाहिए जिसको मैंने स्टार से डिनोट किया है, और कुछ प्रॉपर्टीज को वो सेटिस्फाई करते हैं जिसको हम एक्सिम्स बोलते हैं. जी के लिए ये एक्सिम्स है. ग्रुप एक्सिम्स भी बोला जाता है इसको. सो द पेयर of non-empty set Z with binary composition is called group if these properties are satisfied. Again, if Z is finite, then Z is called finite group. यदि G फाइनाइट है, फाइनाइट का मतलब नंबर ऑफ एलिमेंट्स मस्ट बी फाइनाइट, आप काउंट कर सकते हो. इफ G इज फाइनाइट, परिमित, देन G इज कॉल्ड फाइनाइट ग्रुप, अदरवाइज इट इज इनफाइनाइट ग्रुप. आई रिपीट, यदि G एक अरिक्त परिमित समुच्चय है तो इस समूह G को परिमित समूह भी कहते हैं. सो इफ G is finite, then G is called finite group, otherwise infinite group. So if G is infinite set, then if it is a group, then it is infinite group. Okay, so now today we will discuss these two problems so that the pair where A asterisk B is A plus B minus AB for all AB belongs to this forms an abelian group. Remember, it is not a group, it is abelian group. Means if commutative property holds क्रम विनिमेयता, तो इस ग्रुप को हम abelian ग्रुप या क्रम विनिमेय समूह या कम्यूटेटिव ग्रुप कहते हैं. ग्रुप के लिए केवल ये बात, यदि कम्यूटेटिव प्रॉपर्टी भी होल्ड होती है तो हम इसको अबेलियन ग्रुप बोलेंगे, नहीं तो नहीं बोलेंगे. सेकेंड क्वेश्चन, सो दैट द सेट ऑफ 2 by 2 matrices means square matrix of order 2, these are the elements theta belongs to R, forms an abelian group under matrix multiplication. Forms a group under matrix multiplication. Is this group abelian? क्या ये क्रम विनिमेय समूह है या नहीं? दोनों केस में देखना है. This set is infinite, this set is also infinite, it is not finite set. I just consider one example of finite set. Yesterday we have already discussed. A set of fourth root of unity. जो आपको दे रखा है वो आपको समझ में आना चाहिए. A set of fourth root of unity means it is this. Fourth roots of unity means 1 to the power 1 by 4. It is that. Fourth root of unity. So if I say let x equals 1 to the power 1 by 4 implies x to the power 4 equals to 1, implies x to the power minus 1 equals to 0, implies x square minus 1, x square plus 1 equals 0, implies x minus 1, x plus 1, here इसको आप और x से लिख लो, x minus iota and x plus iota. This is x equals plus minus 1. It is this. We have already discussed a set of fourth root of unity means this. Let us suppose it is the pair where star means multiplication. The binary operation or the operation is multiplication dot. This set is finite set. How to prove this pair is a group? This is a finite set. The best way is to construct the composition table. This part we have already done, and if we consider the composition table, we find that this forms an abelian group. This forms an abelian group. This is finite, so this is finite abelian group. I have already told that this is very important example. Minus 1, 1, iota, minus iota. This into this. Then it is minus 1, 1, iota, minus iota. Okay. Minus iota here, and this is plus iota. Okay. This is minus iota, minus 1, and it is plus 1. Minus minus plus, so it is iota, minus iota, 1, and this is minus 1. Look at this. Here it is, multiplication. All the members, all these are the members of Z. So first, Z is closed under multiplication. Second, multiplication is associated. This is a property, the numbers, multiplication is associative. Third, we can find the identity. One is the multiplicative identity. You can say minus 1, 1 iota, minus iota. Here it is, minus 1, 1, this one. This part is identical to this. Again, minus 1, 1 iota, minus iota. Here it is. मैंने जानबूझकर -1 से स्टार्ट किया, इसलिए जरूर नहीं कि ये फर्स्ट कॉलम और फर्स्ट रो ही आए. यदि आप 1 से स्टार्ट करते तो ये यहाँ बन जाता, बट यू कैन सी. सो थर्ड, 1 is the identity. and it belongs to this. Now we find the inverse. Inverse of -1 is -1. आइडेंटिटी कहाँ दिख रही है मुझे? ये आइडेंटिटी किसके अगेंस्ट में? -1. So this into this. Then inverse of 1 is 1. Inverse of iota कैसे देखते हो? ये रहा आइडेंटिटी एलिमेंट, किसके अगेंस्ट? -iota. So inverse of iota is -iota, and inverse of -iota is iota. Every element has its inverse in Z. First हो गया, second हो गया, third हो गया, fourth. All the 4 properties are satisfied. So this is a group. कैसा ग्रुप है? फाइनाइट. क्यों फाइनाइट? बिकॉज Z is finite. Number of elements finite. So this is finite. Is it commutative? मैंने बताया था commutative कैसे देखते हैं. ये है मेन डायग्राम. This one. Look at the elements equidistant from this. 1, ये 1. इस एलिमेंट की साइड माइनस आयोटा, इधर भी माइनस आयोटा, आयोटा, then माइनस आयोटा, then माइनस आयोटा, -1, then -1. Commutative. So this is finite abelian group. Multiplication of numbers be always commutative. 2 into 3, 3 into 2. Iota into minus iota is minus iota into iota. So this is a very important example. This is finite abelian group. If it is a finite, then one more term is defined, that is order of a group. Order of a group means order of a finite group. ध्यान रखना है. Order of a finite group means number of elements in Z, and that is 4. कितने elements हैं? 1, 2, 3, 4. So what is the order of this group? 4. Order of finite group is a finite number. If the group is not finite, is infinite, then its order is infinite. अब आप नई नई टर्म्स को सीखते जाओगे, इसलिए थोड़ा सा अपने आप को मजबूत बनाना है. वीडियोस को बार बार देखना है. बेसिक कॉन्सेप्ट्स को बार बार आपको ध्यान में रखना है कि मैं किस तरह से पढ़ा रहा हूँ, मैं क्या बताता हूँ. अब आपको नोट करते जाना, क्योंकि अब हम थोड़ा सा आगे बढ़ते जाएंगे. सो ऑर्डर ऑफ अ ग्रुप फाइनाइट इफ द ग्रुप इज फाइनाइट. ऑर्डर ऑफ अ ग्रुप इनफाइनाइट if the group means the set is infinite. Okay, so this is the way to prove the given pair is a group or not. With the help of composition table we can construct if the set is finite. Now we have two problems. In this, both the sets are infinite, and we have already done in the previous video, that is in binary composition. You have already done. Find the identity element, find the inverse of the element. So here it is that. Let us continue this. Okay, so we come to the first question. प्रोसेस का ध्यान रखना है, डेफिनेशन को दिमाग में होल्ड करना है. और काम करते जाना है। प्रूव दैट द पेयर दे रखा है। क्यू का मतलब होता है सेट ऑफ रेशनल नंबर्स। और रेशनल नंबर्स कैसे होते हैं, ये आपका हेडेक है। मैंने बता रखा है आपको कि किस तरह के नंबर्स को हम रेशनल नंबर्स बोलते हैं, रियल नंबर्स बोलते हैं, इसलिए आपको देखना आना चाहिए। इसका मतलब है सेट ऑफ रेशनल नंबर्स अदर देन 1। सेट ऑफ रेशनल नंबर्स अदर देन 1 मीन्स उस पूरे सेट ऑफ रेशनल नंबर्स में 1 नहीं होगा। So this set is given with binary composition where definition is given a plus b minus ab for all a comma b belongs to this। पहला काम जो है कि ये जो ऑपरेशन है वो बाइनरी है या नहीं, मीन्स वी हैव टू प्रूव दिस इज द मेंबर ऑफ दिस पर्टिकुलर सेट्स। ओके, जैसे मैंने लिखा 2 3 बिलोंग्स टू n। ऑपरेशन क्या है, 2:3 2 + 3, ये ऑपरेशन है प्लस के। देन द आंसर इज 5। इट इज 5 बिलोंग्स टू n। Now here it is in the same way because this is not finite set, this is infinite set. So let x comma y belongs to first part। Suppose these two members are the members of this one. Always remember, this is the set of rational numbers other than 1. Obviously, x is not equals to 1 and y is not equals to 1. Now we have to prove that a plus b minus ab is not equal to 1। ये रेशनल नंबर होना चाहिए लेकिन 1 के इक्वल नहीं होना चाहिए। नाउ जस्ट अप्लाई। कैन आई राइट दिस बिलोंग्स टू Q? उल्टा सोचो। Suppose x is 1, y is 1. Then 1 plus 1, suppose I write note. Answer is 2. This is 1. That means this is not the member of this. So we cannot consider x is 1 and y is 1, and here it is written x is not equals to 1, y is not equals to 1. Other than 1 you can consider. You can consider 2 and 1, 2 and 0, whatever you want, but it is not. Okay? Alternative. Alternative. If possible, let's suppose it is 1. मैंने यह लिखा है this is equal to this and this is the member of this one, लेकिन क्या वाकई है या नहीं? If possible, let x plus y minus xy equals to 1. This implies x plus y minus xy minus 1 equals to 0. I consider the pair here इसको और इसको एक साथ ले लेता हूँ. So it is x minus 1 then minus xy plus y equals to 0. Then it is x minus 1 minus y common, then x minus 1. Then it is 1 here, so it is x minus 1, 1 minus y equals to 0. And this implies therefore x equals to 1, y equals to 1, but x is not equals to 1, y equals to 1. Therefore x plus y minus xy is not equals to 1. Therefore x plus y minus xy belongs to. Therefore is closed under this operation. This is the mathematical way to prove. Consider two members. Operate. The answer must be the member of this. Then it is binary. So you consider two members. लेकिन इनका नेचर क्या है? इसमें है 1 नहीं होने चाहिए. x is not equals to 1, y is not equals to 1. Then operate. ये रहा ऑपरेशन. Answer is this. क्या ये इसमें है? ये प्रूव करना है. Because it is infinite set. Is this a member of this? Then take the reverse example. ये 1 नहीं होना चाहिए. यदि 1 नहीं होगा तो इसका मेंबर होगा, नहीं तो नहीं होगा. मान लिया कि ये 1 के इक्वल है. यदि ऐसा करता हूं तो मेरा आंसर आता है x1 और y1 होता है. लेकिन कंडीशन क्या है कि x is not equals to 1, y is not equals to 1. मीन्स ये कब आएगा? जब ये हो. लेकिन x is not equals to 1, y is not equal. इसका मतलब ये 1 के इक्वल नहीं होगा. जब ये 1 के इक्वल नहीं होगा, इसका मतलब ये इसका मेंबर होगा. This is the member of this. And if this is the member of this, that means the operation is the binary operation. In other words, we say this is closed under the given operation. This is the way to prove the first axiom, the first property of the group. Okay, now we come to the second part of this. बहुत ध्यान से लॉजिक अप्लाई करना आना चाहिए आपको. Now we come to the second property, that is associativity. Okay. Number 2. For any 3 elements A, B, C belongs to let us say A as it is B as it is C equals. Apply the definition. A plus B minus B. A as it is B, definition इसकी बात. क्या है definition? दोनों को add minus then subtraction. So here it is A plus B minus A plus C then minus A plus B minus AB into C. थोड़ी देर के लिए अपने दिमाग में इसको x मान लो. So it is x as it is C. So it is x plus C minus xc. Just simplify this. A plus B minus AB plus C minus AC minus BC and plus ABC. So this is A plus B plus C minus AB minus BC minus CA plus ABC. This is the first part. Second one, A asterisk B asterisk C equals A asterisk B asterisk means B plus C minus B C. ऑपरेशन जो दे रखा है वही होना चाहिए, ये ध्यान रखना है, अपनी मर्जी से नहीं. Then single element, suppose it is x, so it looks like A asterisk x A plus x means A plus x का मतलब ये है. Then minus इन दोनों का multiplication A times of this. So it is A plus B plus C minus BC minus AP minus AC plus ABC. This is minus AC. This into this and plus this. And here it is. This part is equal to this part. That means, therefore, A asterisk B equals to, therefore, this is associative. The binary composition is associative. Try to learn how to prove. बोलने में बहुत इजी लगता है. Yes, it is closed. Yes, it is associative. This is identity and this is that. So mathematics is time consuming. Time लगता है इसमें. It needs a lot of practice. It needs a discipline. आपको अपने आप को डिसिप्लिन बनाना है, तभी आप सीख पाओगे. और यदि आप प्रॉब्लम्स को सॉल्व कर पाते हो तो जो प्लेजर, जो खुशी मिलती है उसका कोई मोल नहीं होता है. इसलिए सीखने की कोशिश करें. सो सेकंड प्रॉपर्टी इज सेटिस्फाइड. फर्स्ट, the set is closed means the given operation is binary operation. Then second one, associativity holds. Now third, identity element. Identity. Number 3. Suppose E belongs to data identity element of this binary composition. Now we calculate it. If we find the identity which is the member of this one, then A asterisk E equals to A equals to E asterisk E for all A belongs to Q. ये तो सिखाया था आपको. Always remember, both way you have to calculate, left and right. So let us simplify this. A asterisk, the definition, A plus E minus AE equals to A. A plus E 1 minus A equals to 0. This and this cancel out. E times 1 minus A equals to 0. This implies A equals to 0, A equals to 1. But A equals to 1 does not belong to, therefore E equals to 0. This belongs to Q. The knowledge of equation is very important. मैथमेटिक्स करते समय क्लास 1 से लगा के अब तक जितने भी कॉन्सेप्ट है दिमाग में क्लियर होने चाहिए. कब कौन सा कॉन्सेप्ट कहाँ यूज होता है किसी को नहीं मालूम. सो बेसिक्स आर वेरी इंपॉर्टेंट. लुक एट दिस. डेफिनेशन, ट्रांसपोज, कैंसिल, ई कॉमन, दोनों में से 1 minus A product. Either A equals to 0 or this equals to 0. So A equals to 1. A किसका मेंबर ये, इसलिए 1 हो नहीं सकता. So A equals to 1, but A equals to 1 is not the member of this. ये इसका मेंबर नहीं हो सकता. ध्यान रखना है. फिर A is not equals to 1. Therefore A must be 0. नहीं तो ये बैलेंस नहीं होगा. And it is this one. Therefore, A equals to 0 is the identity element. Member of this. जो भी एलिमेंट बनता है, आइडेंटिटी एलिमेंट बनता है, वो उस सेट का मेंबर होना चाहिए. It is this. इसी तरह से आप इसको सिंप्लीफाई करो. ये आपका काम है, मैं यह नहीं कर रहा हूं. इट इज अप टू यू टू सॉल्व. वेरिफिकेशन देखते हैं. लेट अस सी. 3/2 बिलोंग्स टू, नाउ आइडेंटिटी एलिमेंट को किसी भी एलिमेंट के साथ ऑपरेट किया जाए तो वो एलिमेंट वापस वही आता है. सो लेट अस 0 as is 3/2. क्या डेफिनेशन है? 0 plus 3/2 minus 0 into 3/2. The answer is 3/2. ये देखिए, it is this. So 0 is the identity element of this binary operation. Okay. Fourth part. Fourth. Let X belongs to suppose Y belongs to this. If it exists, be the inverse of x. x मैंने सपोज कर दिया इसमें है. So x is not equals to 1. Y is the inverse of x. If exists, यदि exist करता है, हम चेक करेंगे इसको. If it exists with the inverse of x, and that is not equals to 1, of course. Then, what is the definition? x asterisk y equals to e equals to y asterisk x. भीम दुर्योधन नलिफाइड. मैं बार बार बताता रहूंगा. ये वाला जो एग्जाम्पल है, सेकंड जो क्वेश्चन है उसमें मैंने दे भी रखा आपको. ये एज ए होमवर्क है आपके लिए. इसको हम कल डिस्कस करेंगे, इसलिए मैं यहां से इसको रब कर देता हूँ. इसको होमवर्क को कल क्लास में डिस्कस करेंगे इसको. x plus y minus xy equals to 0, because identity element is 0. If I cancel this part, then here it is 0 equals to y plus x minus yx. Both will be considered. E 0. We have to find the value of y by the inverse of this one. So this is y equals x upon x minus 1. If we simplify this, just transpose y common, definitely the denominator is x minus 1, and we people know that division by 0 is not allowed. So x is not equals to 1, इसलिए हमने 1 नहीं ले रखा है. उस सेट के अंदर इनवर्स कैलकुलेट करने में दिक्कत आती है. What is x? Rational. X minus 1, again rational. Division of two rational numbers, rational number. Therefore, x upon x minus 1 belongs to this. Hence, x upon x minus 1 is the inverse of x. Verification करो इसका. यदि ये इसका इनवर्स है तो दोनों का इफेक्ट नलिफाई होगा और आंसर आइडेंटिटी आएगा. आइडेंटिटी 0 आना चाहिए. सो लेट अस सी x asterisk x upon x minus 1. This is x plus x upon x minus 1 minus x into x upon x minus 1 by definition. दोनों को add minus product. So it is x minus 1 is LCM. So this is x square minus x plus x, and this minus x square. So this and this cancel, this and this cancel. So you see that is the identity. Similarly, if you consider, you just verify yourself. So if I say find the inverse of 3/2, find the inverse of this. What is the answer? Answer 3/2 upon 3 by 2 minus 1. X upon x minus 1. So it is 3 by 2 upon 1 by 2. 3 by 2 minus 1. So this is 3. Okay. Sometimes it is asked in multiple choice. This is the extra information. Inverse of 3 by 2 is 3. Means if we apply 3 by 2 and 3, the answer must be 0 under that composition. Note. 3 as is 3 by 2, that is 3 plus 3 by 2 minus 3 into 3 by 2. This is 3 to the 6 plus 9 by 2 minus 9 by 2, and this is 0. Duryodhan being identity. Now the fifth one, the last. Commutative property. Okay, so let's belongs to now. X plus y. This I can write, and this is nothing of this. Therefore, this is commutative. So, what is the final answer? Hence, this pair is an infinite abelian group. This is a group. Commutative property holds abelian group. The set itself is infinite, so this is infinite abelian group. And what is the order? Infinite, because number of elements infinite. So this is the way to solve the question. Try to understand. How to understand? Second question you have to try. I will discuss tomorrow again in one more example. So thank you very much. God bless you.